Join the summer conversation only on Cape Talk.
It is 35 minutes after 9 o'clock, and you're tuned into Views and News with myself, Saskia Falcon, standing in for Mr. Clarence Ford on this beautiful Friday. And we can now come to probably what is the most popular segment on Clarence's show, The Naked Scientist, or as we know him as Dr. Chris Smith. That's the name his mommy gave him. Good morning, Chris.
Morning,
How are you
morning,
today?
Saskia. Well, you don't know. She might have called me the naked scientist. You never know. She might have been very
Did she?
foresighted. Anyway, Merry Christmas, everybody. I think this is our last programme of the year, isn't it? And another year
It
draws to a close.
is.
How amazing. But anyway, great to be here.
And next year's 2025. Can you even imagine? Can you even wrap your
No,
head around
I
that?
really don't know where the year has gone, to be honest. And it's interesting, isn't it, how our perception of time changes. People say as you get older, time goes faster. I think we get busier, but the best explanation I've heard for why time appears to race as we get older is that each year, as a proportion of all the years you've lived, is smaller. So because your brain judges the amount of time passed by the amount of time you're experiencing as a proportion of all the time you've experienced, time will therefore go faster and faster and faster and faster. So at this rate, I'm going to be
great.
100 before I even know where I stand.
Well, our first question here comes from an older gentleman, Mr. Roland Willis. He wants to know why sound caused him pain for almost a year. He said he hid from noise at any level. He had to basically, he said, teach his brain to accept sounds like an infant is taught to eat. He was told it's called, and I'm not sure if I'm going to pronounce this correctly, hyperacusis?
Yeah, hyperacusis.
Hyperacusis,
Acouse
yes.
as in acoustic sound. And
Ah,
this is, yes, well documented. There are some people with very sensitive hearing, and it can also be a manifestation of hearing damage, as the hearing system tries to compensate for hearing loss because of age-related decline, but also occupational deafness. If we're experienced to lots of loud sounds or a number of periods of extreme loud sound, you can damage the cochlea in the inner ear, which is the structure that converts the sound waves into brain waves that enable you to decode sound. And in some people, that does become distorted, and the ear tries to compensate for the damage, and it amplifies the signals too much across the entire sound spectrum, and some sounds therefore become painful, and people do develop a kind of real sensitivity to certain frequencies or all frequencies, and it can be extremely discomforting, and it can disturb sleep, it can disturb a person's ability to just relax, and it's a bit like tinnitus. That's a different manifestation but related, and people find it equally distracting. So yes, he has my sympathy. We don't really understand exactly how this happens or how to compensate for it, but our theory is that it is damage to the hearing system which causes an oversensitivity to some or all frequencies.
it's very interesting. Roland said he never really listened to loud music. He wasn't ever given a real cause or even a cure.
No, it's a
There is
tricky one,
none.
this one. And it's the same with tinnitus, that some people just develop this as we get older, just because of the rate of decline in all our faculties as we get a bit older. Your ear loses the ability to pick up certain frequencies. We theorize that the brain, because it's not receiving signals corresponding to certain frequencies in the ear, turns up the volume coming from those missing frequencies, but turns up the volume to some of the other frequencies as well. And this creates
As
a sort of
well.
white noise effect, in the same way that if the radio was a bit indistinct, you'd turn the volume up, you bring up the hiss with it. And we think that it's a similar manifestation.
Thank you for that. Let's cross to the lines now. We've got Zuki out in Big Bay with a question. Good morning, Zuki. What's your question for Dr. Chris?
Morning, Saskia, and morning, Dr. Chris. Dr. Chris, I have a colleague who says she is able to wake herself up from her dreams. She says she has very lucid dreams, and she almost like has a formula when she needs to wake up, and it works every time. How is that possible? Are they not sleeping properly? How can people do that?
Hazuki. Well, one wonders whether she was dreaming that she wanted to wake herself up. And so when she did wake up, because it was the dream she was having that she wanted to wake up, it was a self-fulfilling prophecy. Put that to her and see what she says.
Zuki's still there. No, Zuki's left already. Okay. Zuki, it could just be a self fulfilling prophecy type of situation. Oh, that is very interesting. We've got another question on vinegar. And this is from Vernon. When I go to the shop to buy vinegar, on the shelf are spirit vinegar, white and brown, manufactured by the same company. What's the difference in taste or acidity between these two? I'm using these for cooking. Does it make a difference to the dish I'm cooking, whether I use the brown one or the white one, or is there a flavor profile difference? What is the difference? Does it matter?
Well, strictly speaking, chemically, vinegar is acetic acid, otherwise known as ethanoic acid, which is what you get if you oxidize alcohol, ethanol. You turn ethanol into ethanoic acid, and it gives it that vinegary smell and taste. Now, if you start with a pure solution of ethanol and oxidize it, you will get a pure solution of vinegar there, or something roughly approximating it. And so when we see a white or a spirit vinegar, you've started with a concentration of alcohol and not much else, and you've oxidized it to ethanoic acid, and it will therefore just add that acidic flavour to your dish. If you start with some, say, red wine, and you allow that to oxidize, there's not just alcohol in red wine, of course. There's all the other things that give red wine its colour, its chemical profile, its taste, its particular flavours and so on. So those will also be present in the mixture. And yes, it's dark because you started with dark colours, tannins and so on in the wine, and you oxidise the alcohol. So it will make a difference. And this is why people have cider vinegar, where you start with cider and you oxidise a proportion of the alcohol to the vinegar and so on. So different things are going to work well with different dishes. And if you just want the fairly sort of punchy effect of the vinegar, you go for something that's not going to affect the flavour profile, so one of those spirit vinegars. If you want something where you want the notes that are in the wine and you want the acidity, then you'd start with a wine vinegar. And if you want to make some other sort of purer dishes, for instance, I made some, I got some chilies and dissolved some sugar in some cider vinegar and made the most amazing kind of poached chilies. It was fab. It worked because it was cider vinegar, I think because of a fruit with a fruit. Not sure it would have worked quite so well in a red wine vinegar. Perhaps the flavours would have clashed a bit. So it really is horses for courses here.
We're talking to Dr. Chris Smith, the naked scientist. Does it matter, just on the vinegar subject, because I often use vinegar and bicarbonate of soda for cleaning. Does it matter which vinegar you use there?
Well, remember that if you've got stuff already in the solution alongside the vinegar, then that will be left on the surface that you clean, and you've then got to clean that off as well. If you're using vinegar because it's acidic and you have lime scale, one of the really attractive things about vinegar is that because it's a safe food product, you can put it in your kettle and descale your kettle, for instance, and then rinse the kettle out. There are no residues that are going to do you any harm whatsoever. So people find it attractive for that point of view. Cleaning a glass window that's got a bit kind of dirty or scale on it and so on. Vinegar, absolutely fine for that. But if you have things with residue and these colours and things in these other substances that can also be made into vinegar, they're going to leave that residue on the window and might therefore mean that you remove one problem and leave another behind.
Right. Oh, that makes sense. Let's go back to the line now. We've got Stephen from Bellville. Good morning, Stephen. What's your question?
Hi, good day. I'm just wondering, radioactivity affects living organisms, but how and if it does affect inorganic matter at all, and if so, how?
Hi, Stephen. Yes, you're quite right that radioactivity is harmful to life. And the reason for this is the radioactivity can damage DNA and other molecules as well, actually, but it can tear apart the chemical bonds in DNA, causing breaks in the DNA, which when they repair or get re-stitched together, can distort the message in the DNA. It's a bit like scrubbing out some words in the page of a textbook, and then the sentence changes structure, and it may change its meaning. This is what happens when you mutate DNA, and if you do that enough, you can render cells inviable, or you can sometimes damage genes which are involved in repairing DNA, and that means more damage crops up in your DNA, and you're more likely to get cancer. That's all well understood. Well, if you can damage chemical bonds with radioactivity in that way, yes, you can damage other molecules that are not part of life processes as well. And in fact, you can damage crystals with radioactivity. And about 15 years ago, a guy at Cambridge University called Ian Farnan published this paper showing that when we encase radioactive material in, say, glass, because one of the ways we store radioactive waste from the nuclear industry is we vitrify it. You put the radioactivity into a structure and then turn it into a glass, because that doesn't dissolve, it won't leak, it won't do anything apart from just sit there for a long period of time, which you need for the radioactivity to cool down. Everyone thought, well, that's good, that will be safe for thousands of years. What Ian Farnham was able to show, if you want to look it up, it was about 2007 or so in Nature. They were able to show that when the radioactive nuclei decay, spitting out radiation, when they spit out heavy particles called alpha particles, they are so heavy that it makes the nucleus recoil, a bit like when a gun is fired and it hits you in the shoulder. And this has the effect of disrupting the crystal structure of some of these vitrified materials. And after about 5,000 years, the crystal structure can fall apart completely. And as a result of that, you end up with a leaky radioactive store. So it's not a long-term way of storing these things safely, potentially, with some forms of radiation. So the answer to your question is absolutely, these things can damage the crystal structure and other things in nature, not just life processes.
Fascinating. You're, of course, listening to Cape Talk, and we're with the Naked Scientist, Dr. Chris Smith. Can we take Jonathan's voice note, please?
Hi, I've got a question for Dr. Chris Smith regarding anosmia. It's known as anosmia, which is where one can't smell and is born without smell. Just interested to know the science behind that, and is there a possible cure for that? My name's Jonathan from Cape Town.
Thank you, Jonathan.
Hi, Jonathan.
Anosmia.
Anosmia is very common, and most of the time we have it temporarily when we get a blocked up nose or an infection. And usually one causes the other, doesn't it? And the reason there is because a virus, usually, attacks the lining of the nose, and where we smell is at the top of our nose on a sheet of tissue called the olfactory epithelium. And on that sheet of tissue are fine nerve endings which have receptors, chemical docking stations all over them that are sensitive to different molecules that we can smell. And when you breathe in, the air goes up your nose, carrying all the molecules from the environment up your nose. They dock onto those receptors, activate them, and they then fire off messages into the brain, telling the brain what constellation of different smells you can smell. If you damage that tissue with an infection or a blocked up nose, you lose the ability to smell. But similarly, if you damage the pathway that those signals would follow into the brain, or the brain itself that decodes those signals, you will also lose your sense of smell. So the other common reason people become anosmic is usually through head injury, because when a person has a rapid decelerating injury to the head, if you have a car accident, for example, or you fall off a horse, fall off a bike and bang your head on the floor, because the nerve endings that run up from the olfactory epithelium go into the brain through, it's a structure called the cribriform plate. It looks a bit like a sieve, and the nerves go through the holes in there and into the brain. Because the brain can move around inside relative to the skull, it can tear those nerves off and they never grow back. And so a person is disconnected the circuitry and they can't smell for that reason. And then the point that is raised in this question by Jonathan is, well, some people are born without the ability to smell, and what's going on there? There are conditions that can be inborn that will lead to the same sort of problems. One of them is called Kalman's syndrome, and this is where the cells in the brain that receive the smelling signals and then help to decode them and transmit those signals onto your consciousness, they don't migrate into the right part of the brain when we're developing inside our mum. So although the signals will come from the nose, they've got nowhere to go. It's a bit like a telephone where you haven't plugged the telephone into the socket in the wall. And so you can pick up the phone, you can try and have a conversation, but there's no one able to hear you. And that is the other reason why we tend to get some inborn forms of anosmia.
Let's cross to the phones now. We've got Janine from Malpo Strand and a question on stoves. Good morning, Janine.
Hello, everyone. So yesterday I burnt one batch of shortbread. The other was okay, but it was because I forgot to switch from thermofan to regular oven. And my question is, why is it that the thermofan, where your oven is set at the same temperature, why is it that it cooks food more than when it's on regular oven?
Right.
Great question.
Okay.
But I've overcooked it too.
Yep.
Thanks, Janine.
The way that ovens work is, it sounds pretty basic, doesn't it? That, well, we've got a thing that's hot and you put food into a hot place and the food gets hot. But what's actually going on is quite clever, because the body of the oven on all sides is hot and the heat goes into the food by direct contact from the bottom of the oven because of the metal floor of the oven, injecting energy directly by conduction into the bottom of the food. The sides of the oven are also very hot, and so they're going to radiate heat at the food, because any surface that is hot is radiating energy. In the same way that if I hold my hands out towards my fire, I can feel the warmth on my fingers. That's because the fire is radiating infrared at my hands and they feel warm. The food is feeling the radiation of the infrared from the sides and top of the oven. But the other thing that's going on is air inside the oven is a relatively poor conductor of heat, but it will, if it's in contact with the element, get very hot. So if you have a fan in the oven, you can move the air past the element, make it hot, past the food, and make that hot, and then move the air that's now taken away some of the coldness from the food and imparted energy into the food, take that away and replace it with more hot air. So you're increasing the rate at which you can put energy into the surface of the food, because the air's going over the surface of the food. The air also will dry the food, because the movement of the air will pull water out of the food. And when water is in the surface layer of the food, it will evaporate, keeping the temperature down. But once it dries the food out, there's no more water to evaporate, and the temperature can climb much more rapidly to a much higher level, and that means you're more likely to burn the food. So that is how a fan oven enhances cooking, but also enhances your chances of burning things if you're not careful.
Like the shortbread biscuits. Thank you so much, Janine. I think we also have a voice note from Alan, something about more than one universe.
Hello. It's Stuart in Muizenberg for Dr. Smith. Just wondering if he would think a model of the universe could consist of two concentric universes, one being a pretty empty antimatter outer shield, and the inner one being a full universe with us living in it. Thank you very much. I'll listen on the radio.
Oh, fascinating question. Thank you, Stuart.
Hello, Stuart. Well, to be honest with you, as one physicist put it to me once, you have to be really careful with theories, because you can prove anything on paper. The reality is something quite different. And we really don't know anything about any of this. All we know is that we're here and we're in a universe. But are we in the only universe, or are there many universes? Some people, Michio Kaku wrote a book called Parallel Universes. It's quite a dense read, but it's an interesting one. Take a look at that explains the prospect of there being multiple universes. But one of the other questions being hinted at here is, well, this thing about antimatter. Because part of our understanding of the physics of the universe is that there is matter, stuff that we're made of, and that's about 5% of the universe. But we know that you can also make a mirror image of the stuff we're made of, antimatter. And when the two meet, they annihilate one another. And we know this happens because we make antimatter and we use antimatter all the time. If you go for a brain scan, if you go for a PET scan, a positron emission tomography scan, you are given a substance which is metabolized, for instance, in highly metabolically active tissue. And because it concentrates in that area, when it concentrates in that particular area and spits out a particular form of material, it produces some antimatter, which then meets the matter, annihilates, and produces a signal that the scanner can see. That's how it works. So we know antimatter's there. But our big question is, well, all of our theories about how the universe formed should, in theory, produce matter and antimatter in equal amounts. But when we look out there in the universe, we find about 5% of everything we can see in the universe is matter, and we don't see any antimatter. So where is it? No one knows, no one has any idea, and it's one of those big conundra that we still don't have the answer to, but physicists are always reaching and searching for possibilities. So I'd say no bets are off here.
And the two concentric circles, that means you can make anything work on. Of course, it could work in theory on paper.
Who knows?
Yes. I've got a question in from Keith. Keith says, I've watched videos of people on roller coasters screaming and then all of a sudden passing out for a few seconds and then coming back screaming again. as if nothing happened. What is going on? What is the reason for this?
I don't know. I'd have to think about that one. I don't think they actually pass out, but it's possible that they might transiently, because we know that, for instance, when a fighter pilot pulls a particularly powerful maneuver in their fast-moving jet, that unless they take precautions and inflate a special suit that can control where the blood goes in their legs, for example, they can pass out. They can have a blackout, or if all the blood rushes up to their head, they can have a red out, which is when too much blood goes through their brain. So it could be that these people on the roller coaster are transiently depriving their brain of a bit of blood flow, and that makes them feel a bit woozy for a second because of pulling a lot of G's as they go around a corner. But I'd have to think about that one. It might just be they're so awed by the ride that they don't know what to say, they don't know what to scream. But it's an interesting idea. It might be that they're experiencing transient fighter pilot syndrome. I'll have a think about it, and that's one for 2025.
Fantastic. Thank you, Keith. Last call. Let's go to Mervyn in Strand. Good morning, Mervyn. What is your question?
Good morning, Dr. Chris. I would like to, if you can explain the phenomenon where my wife, if 5 babies is crying, she'll know exactly if it is her baby crying. The other thing is, we had twins, and she would know if she's in the other room, she would know which one is actually crying.
Fascinating.
But for me, I can't figure that out.
Thanks, Mervyn.
Well, I'm minded of what happens down in Antarctica, where all those penguins have all those babies, and there are thousands of them. And the parents will go off and they'll go hunting. They'll come home with a stomach full of fish after an extended period of hunting at sea. They'll come home and they will find their mate and their babies. And they do it almost certainly by sound, but by vision as well. But sound plays a massive role. And if birds can do it, not so surprising that we can do it too. If you think about it from an evolutionary point of view, we would be pretty poor parents if we were not very good at recognizing, finding and helping our babies. So I suspect it's because any parent, their brain, the minute you have a baby, especially women, but men also, and women have a tighter chemical bond with their baby, because as soon as the baby's born, it produces chemical changes in the brain of the mother, especially when they first breastfeed. You produce a big burst of oxytocin, which rewires various bits of the brain, and that's how bonding happens. I strongly suspect that in the same way that that's happening, there is a strong memory trace laid down of what your child sounds like, smells like, feels like, sounds like, etc. And this is all being brought to bear.
Fascinating. And the fact that the twins, well, I suppose they're twins, but they would have different voices.
Well, they might be non-identical twins, of
personalities.
course. Not all twins
Yeah.
are identical. Only a small minority are identical twins. And if they're two different sexes, then they're going to sound a bit different,
Right.
possibly, aren't they? But everybody, if you're not identical, everyone's a slightly different shape. And if you're a slightly different shape, head's different shape, throat's different shape, you're going to produce slightly different sounds. And therefore, you
Right.
can be discriminated in that way.
Well, thank you so much. What a wonderful session to end off our 2024. Will you be baking any biscuits? Smith?
I actually have a wife and a daughter who are both fabulous at doing this kind of thing. And so I just get out of the way and let them do it, because there's no way I can compete.
Fantastic. Well, we will see you again in 2025. Have a blessed Christmas.
Yeah, have a lovely Christmas, everybody, and a wonderful new year, and see you all in 2025.
Thank you so much. That's, of course, The Naked Scientist. We'll be back.
Only on Cape Talk.